Okay, in this video, what we're about to do is to look on the relationship between the factors and the remainder of a polynomial. As you can see on the board, we have x cubed plus 4x squared plus x minus 6, which is equal to the factors that we have, which is x minus 1, x plus 2, and x plus 3. We're going to use those or one of those to help us to understand what happens between the relationship of the factors and the remainders that we'll get. Now let's focus on the first one here, which is x minus 1. If x minus 1 is a factor, then x minus 1 should equal to 0, which would give us the zeros because we would have 1, 2, 3 zeros we could work with. Therefore, x is equal to 1. What this means is if I should evaluate f of x using 1, I will get a remainder of 0. That's my remainder of 0. Why? Because the factor would have divided fully, okay, into the dividend, giving us a remainder of 0. Now, let us first evaluate f of 1 and see what we get. F of 1. 1 to the third plus 4. 1 squared plus 1 minus 6. This 1 to the third is 1. This is 4. This is 1 minus 6. 1 plus 4, 5 plus 1, 6 minus 6 gives us a 0. And this 0 that we're talking is actually a remainder. Right? This 0 that we're looking at is a remainder. So as you could see, x minus 1 is indeed a factor, because when it was used to divide into this, we got a remainder of 0. So evaluating f of 1, since x is equal to 0, then we see that the remainder is 0. Alright, let us look at using synthetic division, just to prove that this divide into this to give a remainder of 0. Let's look at synthetic division. What synthetic division does is that at the end, the last number is our remainder. Alright, so it tells us what the remainder is. It could be any number. It could be a positive or a negative number. Let's look. In synthetic division, we'll be using 1. So this 1 is our coefficient. 1, all the coefficients, we're writing them. All the coefficients, we're writing them. So we start by bringing down this here, then we start the multiplication, then we add. So 1 times 1 is 1. Then we're going to be adding 4 plus 1, that's 5. 1 times 5, that's 5. We'll be adding 1 plus 5, that's 6. 1 times 6 is 6. So negative 6 plus 6, that's a 0. And we could now see the direct relationship between the end result of the synthetic division. This number at the end is our remainder. So we could see when we evaluate f of 1, it gives us the same remainder as if we had divided x minus 1 into the polynomial. Now let's prove it by using something that is not a factor. Alright, let's use something that is not a factor. So since those are our 3 factors, I'm going to choose a random number and use it. For example, I'll use a factor x plus 1. We know that this is not a factor because these are the 3 factors. So x plus 1 is equal to 0. Therefore, x minus 1 is the value for x is equal to minus 1 would be the value for x, which means if I evaluate the function using negative 1, then I will get some remainder that is not 0. Why? Because this is not a factor. Therefore, I will get a remainder other than 0. Let's see what we'll get. So I'm going to evaluate the fraction using negative 1. So what we have is negative 1 to the third plus 4 times negative 1 squared plus negative 1 minus 6. This is going to give me negative 1, because negative 1 to the third is negative 1, plus 4 times 1, which is still 4, minus 1 minus 6. 4 minus 1 minus 6 is 4 minus 8, which is negative 4. So we're seeing where this remainder is negative 4, right? All right, which means that f of negative 1 gives us negative 4. What I'm going to do quickly is to evaluate or to divide x plus 1 into the polynomial using synthetic division. So if I'm using synthetic division, I'll be using minus 1 there. This is a 1, this is a 4, this is a 1, this is a negative 6. This one would start it, I bring it down. So we're going to multiply, then add. Negative 1 times 1 is 1. 1 plus 4, 5. No, my bad. Negative 1 times 1 is negative 1. Negative 1 plus 4, that's 4. That's 3. Negative 1 times 3 is negative 3. Negative 3 plus 1 is negative 2. And then now, negative 1 times negative 2 is positive 2. So, negative 6 plus 2, you could see the negative 4 is coming back. This negative 4 right there. So, we are seeing that we actually divide throughout using synthetic division, which means that negative x plus 1, if divided into this, we will get a remainder of negative 4. And at the same time, if we evaluate f of negative 1, we will get negative 4. Now let's see what we could conclude regarding the factor and the remainder. Now a quick conclusion that we could draw is that if x plus p is a factor, then if we should evaluate f of negative p, our response will be the remainder. And that is the direct relationship between the factor of a polynomial and the remainder that you'll get. Thank you for watching. Subscribe.